Hello, everyone. The solar system is a vast and intricate structure that has fascinated humanity for millennia. It's a dynamic and complex system comprising the Sun, 8 major planets, their moons, dwarf planets, asteroids, comets, and other celestial objects, all bound together by the force of gravity. The Sun, a massive star at the center of the system, is the primary source of energy for all the bodies orbiting around it. It's a hot ball of gas, mainly hydrogen and helium, undergoing nuclear fusion in its core, which releases enormous amounts of energy in the form of light and heat. This energy is what sustains life on Earth and drives the weather, climate, and various geological processes on our planet. The planets, in order of their distance from the Sun, are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Each of these planets is unique, with distinct characteristics and histories that reflect the varied conditions under which they formed. The inner planets, Mercury, Venus, Earth, and Mars, are often referred to as terrestrial planets because of their rocky surfaces. In contrast, the outer planets, Jupiter, Saturn, Uranus, and Neptune, are gas giants, except for Uranus and Neptune, which are often classified as ice giants due to their composition. Mercury, the closest planet to the Sun, is a small rocky world with extreme temperature variations between its day and night sides. Its proximity to the Sun means it has a very short orbital period, completing a circuit around our star in just 88 Earth days. Mercury has virtually no atmosphere, so temperatures can soar to over 430 degrees Celsius during the day and plummet to minus 180 degrees Celsius at night. Its surface is heavily cratered, similar to our moon, indicating a long history of impacts from meteoroids and comets. Next is Venus, often called Earth's sister planet because of its similar size and composition. However, Venus is shrouded in a thick atmosphere composed mainly of carbon dioxide, with clouds of sulfuric acid, making it the hottest planet in the solar system. The greenhouse effect on Venus is so intense that surface temperatures exceed 460 degrees Celsius, hot enough to melt lead. Venus also has a day longer than its year due to its slow rotation, taking about 243 Earth days to complete one rotation on its axis, while it takes about 225 Earth days to orbit the Sun. This planet's surface is covered with volcanoes, vast plains of lava, and mountains, with an atmosphere so dense that the pressure at the surface is 92 times that of Earth's. Earth, our home planet, is the only place in the solar system known to support life. It is unique because it has liquid water on its surface, a stable climate, and a protective atmosphere rich in oxygen and nitrogen. Earth's atmosphere shields us from harmful solar radiation and helps regulate temperature, creating a stable environment where life can thrive. Earth has one natural satellite, the Moon, which has a significant impact on our planet by affecting the tides and stabilizing our axial tilt, which in turn helps moderate the climate. Mars, the red planet, is the fourth planet from the Sun and is of particular interest because of the potential it once had to support life. Mars has a thin atmosphere, composed mostly of carbon dioxide, with surface temperatures that can vary greatly from minus 125 degrees Celsius in winter near the poles to 20 degrees Celsius in the summer at midday. The planet's surface is covered with iron oxide, giving it a reddish appearance. Mars has the largest volcano in the solar system, Olympus Mons, and a canyon system, Valles Marineris, that dwarfs the Grand Canyon on Earth. There is evidence that liquid water once flowed on the surface of Mars, and today, water ice exists at the poles and beneath the surface. This raises intriguing questions about whether life ever existed on Mars, and if it might still exist in some form today. Beyond Mars lies the asteroid belt, a region filled with rocky remnants from the early solar system. These asteroids are thought to be leftover building materials that never coalesced into a planet. Some of these objects, like Ceres, are large enough to be classified as dwarf planets. The asteroid belt serves as a boundary between the inner terrestrial planets and the outer gas giants. Jupiter is the largest planet in the solar system, a gas giant with a mass more than 300 times that of Earth. Jupiter is composed primarily of hydrogen and helium, and it has a strong magnetic field and more than 75 moons, including the 4 large Galilean moons, Io, Europa, Ganymede, and Callisto. Jupiter's atmosphere is known for its great red spot, a massive storm that has been raging for at least 400 years, and its bands of clouds that give the planet a striped appearance. Europa, one of Jupiter's moons, is particularly interesting to scientists because it is believed to have a subsurface ocean beneath its icy crust, making it a candidate in the search for extraterrestrial life. Saturn, the sixth planet from the Sun, is best known for its stunning ring system, composed of ice particles, rocky debris, and dust. Saturn is also a gas giant, similar to Jupiter, but it has a lower density, so much so that if there were a body of water large enough, Saturn would float. Saturn's rings are incredibly complex and dynamic, with gaps and divisions caused by the gravitational influences of its many moons. Titan, Saturn's largest moon, is larger than the planet Mercury and has a thick atmosphere rich in nitrogen. Titan's surface is covered with lakes and rivers of liquid methane and ethane, and beneath its icy surface, there may be a subsurface ocean of water and ammonia, another intriguing location in the search for life beyond Earth. Uranus, the seventh planet from the Sun, is unique because it rotates on its side, possibly due to a massive collision early in its history. This tilt gives Uranus extreme seasonal variations, with one pole facing the Sun for decades before switching. Uranus is often classified as an ice giant because, in addition to hydrogen and helium, it contains more ices such as water, ammonia, and methane. Methane in the atmosphere gives Uranus its blue-green color. The planet has a faint ring system and 27 known moons, with Miranda and Titania being the most prominent. Uranus is also one of the coldest planets in the solar system, with temperatures dropping to -224 degrees Celsius. Neptune, the eighth and farthest known planet from the Sun, is similar in composition to Uranus and is also classified as an ice giant. Neptune is known for its deep blue color, which is due to the presence of methane in its atmosphere, and it has the strongest winds in the solar system, with speeds reaching up to 2,100 kilometers per hour. Neptune has a faint ring system and 14 known moons, with Triton being the largest. Triton is unique because it orbits Neptune in the opposite direction of the planet's rotation, suggesting it may have been captured by Neptune's gravity rather than having formed alongside it. Triton is also geologically active, with geysers that erupt, spewing nitrogen gas into space. Beyond Neptune lies the Kuiper Belt, a region filled with icy bodies, including dwarf planets like Pluto. Pluto, once considered the ninth planet, was reclassified as a dwarf planet in 2006 due to its size and the fact that it shares its orbital zone with other similar-sized objects. The Kuiper Belt is thought to be the source of many comets that enter the inner solar system. These icy bodies can have highly elliptical orbits, taking them from the cold outer reaches of the solar system to the warmer regions near the Sun. The solar system extends even further beyond the Kuiper Belt into the realm of the Oort cloud, a hypothetical, distant region filled with icy bodies that is believed to be the source of long-period comets. The Oort cloud marks the outermost boundary of the solar system's influence, where the Sun's gravitational pull is weaker and where interstellar space begins. The formation of the solar system began about 4.6 billion years ago from a giant molecular cloud of gas and dust. Over time, gravity caused the cloud to collapse and form a spinning disk, with the Sun forming at the center. The remaining material in the disk clumped together to form the planets, moons, and other bodies. The solar system has remained relatively stable over billions of years, but it is constantly evolving, with planets and moons undergoing changes due to geological processes, impacts from asteroids and comets, and the influence of the Sun. Our understanding of the solar system has grown immensely since the days of early astronomers, thanks to advancements in technology and space exploration. Probes like Voyager, which have traveled beyond the outer planets, and telescopes like Hubble, which have provided detailed images of distant worlds, have expanded our knowledge and continue to raise new questions about the nature of our cosmic neighborhood. In summary, the solar system is a remarkable and diverse collection of celestial objects, each with its own unique characteristics and history. From the scorching surface of Mercury to the icy expanse of Neptune and beyond, the solar system offers a glimpse into the processes that have shaped not only our world, but also the countless other planetary systems in the galaxy. Understanding the solar system is not only a scientific endeavor, but also a journey that helps us comprehend our place in the universe and the fundamental forces that govern the cosmos. Thanks for watching. Subscribe to the channel, like, comment, and share.